Hey, what's going on, guys? Let's do this problem right here. The first question is asking, there were three loops of wire shown in the figure are all subject to the same uniform magnetic field B that does not vary with time. Loop 1 oscillates back and forth as the bob in a pendulum. Loop 2 rotates about a vertical axis and loop 3 oscillates up and down at the end of the spring. Which loop or loops will have an EMF induced in them? Now let's see how we can find it. So first thing we have to know is that in order to magnetic flux to change, there has to be a rotation, right? So here they are saying this one is going back and forth, this one is going up and down. So these two are not rotating. So these two is not going to have a flux, right? So this is the only one that's rotating. So this one is going to have the flux. Therefore, this is the only one going to have induced EMF, right? So this is going to be the answer. Therefore, the answer is going to be loop 2. Now let's look at the next question, the second question. The figure shows 4 different sets of insulated wires that cross each other at right angles without actually making electrical contact. The the magnitude of the current is the same in all the wires, and the directions of the current flow are as indicated, for which, if any configuration, will the magnetic field at center of the square formed by the wires will be equal to 0. Now let's see how we can find it. So in order to be 0, we have to know that this has to cancel each other. The magnetic field's direction, like if this come out and this goes in, that's way it's possible 0, right? So let's go ahead and find the direction of magnetic field and analyze. Now let's look at this one. We have to use right hand rule. So we point our thumb toward this current's direction, and if you curl this one, you will notice for this one, this is going inside. The magnetic fields will go inside. And let's look at the other one. So this one coming outside, the bottom one, right? This one coming outside. So this one can cancel each other. So there's a possible 0 right here, but we have to look at this two side too. Now let's look at this one. If you point your thumb down and if you curl it, you will notice this coming outside of this one, and if you curl this one for this one, you will see this one also coming outside. So this side won't cancel each other. So the first one will not work because we have to have 0. So if one of them opposite direction, we can say there will be a 0, but since both of them are in the same direction, there's no 0. Now let's look at this one. So if you use your right hand rule, you will notice this one goes inside, and for this one, if you use right hand rule, this one comes outside. So this is possible 0 right here. Now let's look at this one. So this one, if you curl your hand, this will go inside, and again if you curl your hand, again this one also goes inside. So both are in the same direction, there's no possible 0. Now let's look at the third one, and if you curl, point your thumb toward current's direction, and if you curl it, you will notice this will go inside, and the other one, you will notice this comes outside. And now let's look at the top one. If you curl it, this will go inside, and for this one, this will come outside. So here we have possible 0. Now let's look at the other one too. So here we have this one. So let's look at the direction. So if you point your thumb toward this current's direction, and if you curl it, this is coming outside, and the bottom one, and point your thumb's direction, curl it, this is going inside. There's a possible 0. Now let's look at this one coming outside, and this one also coming outside. So this is also not going to work. So answer for this one is going to be C. So C is going to be the answer that has magnetic field is 0 at the center. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.